Good morning, everyone, and welcome to our webinar on floating PV technical deep dive with Ciel Terre from the market to the field. Thank you, first of all, for being here. My name is Dana Metaxas, and I am the content developer of the Solarplaza Floating PV Summit taking place in Rome on the 5th of October. And today I will be moderating this session. So before I go ahead and introduce our speaker of today's webinar, let me give you some practical information and some background information about who we are and what we do. This webinar is somewhat of a jumpstart to our Floating PV Summit. And if you're interested in attending the summit, you can find the speaker lineup and the content as well as the event tickets on our website. The great news is that if you are currently attending this webinar, you are eligible for a 15% discount, which will be valid for the next 32 hours for your events ticket. And for those who have signed up but did not attend, will be eligible for a 10% discount. More information on this will be coming from our marketing team after this webinar, and they will also provide you with the discount codes. We want to make this webinar as interactive as possible, so I do invite you to send in your questions as soon as you come up with something that you would like to know more about. Just share your thoughts in the question box on your right-hand side at any time during the webinar. And the recording will be made available to you hereafter within the next couple of days. And again, our marketing team will be providing you with more information on this. Yeah, so let me give you a bit of a background about who Solarplaza is in case this is your first webinar with us. In a nutshell, we are a knowledge-sharing platform with a mission to accelerate the energy transition. We were established in 2004. We're based in Rotterdam in the Netherlands, but we organize events all over the world. So far, we organized approximately 200 events in 44 countries worldwide and counting. We are currently connecting a network of over 60,000 solar PV professionals. And besides our events, we also provide newsletters, resources, and as you can tell, webinars. Besides our platform, we also have a consultancy branch as well as a foundation. So if you're interested in the types of services we provide there, you can also have a look at our website. So that was all I had to share from my end. And without any further ado, I would like to welcome Thomas Vatin, Product Marketing Manager at Ciel Terre, where he acts as the matchmaker between the field, the market, the customers, and the development of new floating technology. Thomas, thank you so much for being here today, and I will let you take it away.
Thank you, Dina, for the introduction. Good morning, good afternoon, and good evening to everyone that is joining the webinar. I'm glad to be presenting this webinar by hosting by Solarplaza. So the topic of today will be floating PV technical deep dive with Ciel Terre. We'll begin our journey from the market observation, and we'll go directly to the field and the case studies that we installed so lately on the floating market. My name is Thomas. I've been involved in the floating solar industry for more than 5 years now, and today I will be very happy to welcome you for this session provided by Ciel Terre. So first of all, the table of content of the presentation today. We'll have a look at the market's observation and trends that Ciel Terre have been observed lately. Then we'll move to the floating solar solution that is provided and available on the market. The last one, we'll go through the case studies and the field application with the specific challenges that we've seen, talking about anchoring, nearshore application, as well as site and requirement basically. Just a quick overlook about Ciel Terre history. So it has been created in 2006, only focusing on rooftop and ground-mounted back then. And the entire activity switched to floating solar in 2011, where we developed the Hydrelio technology, Hydrelio patented technology, which is the first bankable system available at industrial scale. And later on, in 2013, the world first utility scale, so reaching 1 megawatt project was installed in Japan, which was followed by the Ciel Terre Japan creation. Later those years, after those years, basically Ciel Terre opened other branches in US, Taiwan, India. And since 2020, Ciel Terre became a gigawatt player on this specific PV application. Just a few numbers to give you a rough idea of Ciel Terre expertise. So we have around 290 projects installed so far over more than 30 countries, but for a total capacity of 840 megawatts. Today, currently with the installed, under construction and contracted projects, we reach 1.6 gigawatts so far. Around 200 people are involved in daily activity at Ciel Terre. And we are proud to say that we have dedicated 13 years of our time to floating solar. So now let's move for the first part of the presentation, which is the market observation that we've seen. Well, first observation is concerning the pond in itself, or the basins, as we can say. And it's concerning the unique character of it. Especially when you are talking about ponds, you are looking at the different sites environments. And despite specific characteristics, we can gather those ponds into 4 different categories. So first, we have the static freshwater bodies, which is the historical FPV application, where you could have no waves and freshwater. It refers mainly to irrigation ponds and fish ponds, basically. And on this specific segment, Ciel Terre have 12 years of experience and nearly 345 megawatt peak installed. Next one is about inner waters, so which are ponds a bit bigger than the one we just mentioned, where we have some dynamic effects as well, with waves coming to the pond, wave coming to the FPV array. And it refers to the Quarry Lake, larger fish ponds or larger irrigation ponds, water treatment or storage ponds. And on this specific segment, Ciel Terre have 10 years of experience and more than 330 megawatt peak installed. Next one is large inner waters. So it's the same inner waters, but even bigger, with the pond started from 100 hectares, with more challenges at some point. So it represents all the hydro dams and large reservoir, very large reservoir, where basically you could have as well some brackish water. On this specific segment, Ciel Terre have 7 years of experience and nearly 800 megawatts installed. And last but not least, the last segment that we mentioned here is nearshore protected. So it's all the protected bays from offshore conditions, basically, with the sea lagoons that are open to salty water, where we can find as well some waves coming at a bigger scale on the array. And on this specific segment, Ciel Terre have 3 years of experience and nearly 90 megawatts installed. Now moving on to the second observation that we've seen, which is concerning the trend on the PV side. I'm not going to the full history of solar PV cells, solar wafer cells, but I'm just giving you the latest updates concerning that one. Back in 2010 and 2012, we were considering M0 and M2, which were 156 millimeter cell size. And basically with this, it brings 2 types of PV. One was 60 cells arrangement, and the other one was 72 cells arrangement, which become later half-cut cells, so 120 and 144 half-cut cells. At the real standardization, at the real beginning of the standardization, so PV were 1.6 meter by 1 meter. up to 2 meters by 1 meter with the 72 cells. Moving on later with few more improvement in terms of PV arrangement or PV aspects. So M6 arrived in 2019 with PV reaching today 500 watt peak with a new format as well coming onto the market with 78 cells. And basically at that time, those PV were considered quite new, but today they are considered as old PV system as they are not expected to be installed on industrial scale for larger projects. We are moving to now M10 and M12, respectively introduced in 2020 and 2021, with even bigger module capacity and same amount of cells, but the cells increase in size, so the PV itself increase in size. As you can see here, for M12, 78 cells, we have nearly 2.4 by 1.1 meter PV size, so which is around 2.7 meters square, and the PV capacity can reach 620 watt peak for the latest one. And later with M12, so we have a new arrangement of cells on the PV, which is representing 66 cells. And basically with this PV, we are able to reach today 700 watt peak for a module. And at that point, the panel also increased in terms of width and length as it's become 2.4 by 1.3 meter long. These panels are considered as a new PV system, so they will be used on a utility scale project, FPV project scale, and are the main focus of today's presentation as it will be able to be installed with solution that is provided by Ciel Terre. One of the main drivers here is the cell efficiency. Before, with the whole PV system, we were around 18 to 20% maximum, and today we are around 21 to 22% for efficiency. And the higher efficiency is, the lower LCOE will be. So the better the better for the PV industry at one point. Next point and next observation is concerning the FPV system overall and its variety of system basically. So we have seen multiple types of floating solar system arriving onto the market, flourishing to the market, that can go into diverse kind of direction. But at some points, the main objective is the same, setting some PV power plants above water surface. And for that, we have a look at this overview. So different type of system with specifically different type of description and characteristics. First one is float-to-float segment, I would say, which is a float combining with other floats, which provide a flexible structure with waves and salty environment and can lay easily onto the ground. Then we have pipes and hybrid system, which can be described as a mix of flexible and rigid structure. These bring as well buoyancy spread and working stability. Third segment is about pure rigid, which is a float that is set onto a structure, onto a rigid structure, which has high distance above water, which can provide snow resistance and density as has higher PV panel tilt. Pontoon segment, which can be made of FRP, so fiber reinforced polymer, or concrete base floats with a rigid structure on the top, which is quite heavy and stable at some points, which provides as well longevity for some specific cases and have a high degree of prefabricated process. Next one is membrane, which is a specific segment for fabric technology with a flexible mattress or flexible thin fabric that is set onto the water, which provide aerodynamism, can be as well increase the cooling and have some salty compliance as well. And based on those, basically all those segments, we are able today to to give some numbers about the FPV cumulative capacity that has been installed worldwide. So based on internal Ciel Terre and consolidated data from third parties, we are able to say that mid of this year, 2023, the overall cumulative capacity was reaching 5.7 gigawatts, counting over 950 projects. And if we go deeper into this number, taking in consideration those 5 different segments, today float to float is reaching 70% of the overall market share, followed by pipes and hybrid with more than 16%, and third on the podium we have pure rigid. With these 5 different segments, we are able as well to have a look at the evolution and how the technology evolved during the time. So basically, we will get back all those type of technology and start with the first I would say year that is mentioned here in this graph, so 2011, where the FPV market was below 1 mega, and still at that moment we have several type of technology, several type and several kind of technology that were on the market. And later on, in 2015, the market reached 70 megawatts, with actually coming with more technology on the field. So we reached 6 technology for float to float in 2015. Pipes and hybrid with 5, rigid was 5, pontoon 2, and membrane still 0. Later on in 2019, 2018, it was a milestone year for FPV as it reached and then exceed 1 gigawatt, FPV exceed 1 gigawatt at some point. So PV experts starting to say that FPV is the new application for PV, and that will become the third pillar of PV industry. And today, mid-2023, here are the numbers. So following the trend that we've seen so far from early beginnings, with a lot of new technology arriving on the market, but not with the same return on experience, basically. And tomorrow, basically, we'll see that based on DNV information published in April last year, that the capacity in 2025 is expecting to reach 10 giga at some point. For sure, it shows that it is showcasing that FPV is showing a market dynamism, but in terms of technology and reliability, that's here the main point of the discussion, because once we are looking at the actual structurist and the floating solar experts, there is always a gap, especially talking about anchoring, and that's why Ciel Terre have the main expertise on the field, basically. But I will a bit outline it later during the presentation. Now let's move on to the actual solution that we can provide today, talking and considering where we started. So basically, it all started in 2011 with a classic version. It was the first industrial scale FPV structure with a fixed tilt of 12 degrees. At the end of 2011, Ciel Terre reached 3 projects installed with this technology. Later on, Equator version was unveiled on the market for equatorial regions, especially with bringing a fixed tilt of 5 degrees. And at the end of this year, of that specific year, we reached 30 projects installed. Later, it was replaced by Air version in 2019, which is a variable solution with a variable tilt, adjustable fixation, that can cope as well with M10 standard PV size. And today, and at that time in 2019, number of projects was reaching 170 plus, mostly installed in Asia. Today, we are proud to propose the new versatile and the most versatile option, which is Optima Floats, which has variable tilt size, variable float size, and adaptive to a specific M10 or M12 PV module. And number of projects grew significantly in those last years, reaching the number of 290, basically. Talking about track record, what we've seen in 2011 starting in 2011 with Classic is that the track record today of the solution is 430, which is no more commercialized because it has been replaced. Equator was 25, and Air is still 385 megawatts. And in the pipe currently with Optima solution, there is around more than 3,100 megawatts peak. Based on the first and the second observation about the PV tilt, so we've seen that Hydrelio has evolved, and that the PV width and PV length evolve in a time because of the cells in itself. And Hydrelio structure, float-to-float structure, just evolve throughout the time based on the PV that we will install on the power plant. So it started with Classic, as mentioned, so 1.6 by 1 meter. It moved to 2 meter by 1 meter with 72 cells. So Classic were covering a range of compatibility that was in line with the market. After Air came to the market, so here is the compatibility range for Air product with specific size of PV, basically. And now that we are moving to M10 and M12 PV size, Optim is the solution, and Optim can cope with this very large and very long PV that you can find on the market. But what's behind Optim? Let's have a look together. Optima System is a float-to-float technology based on 12 years experience and evolution that we mentioned so far. Its track record and its bankability. It's a float-to-float system combining several types of floats with PV installed in landscape mode, adjustable in terms of angle. So the module can go from 5 to 12 degrees. It can cope with different type of environment as it is combining several floats. It is flexible to adapt to inshore and nearshore condition with the waves, as well as the wind, basically, that can blow quite significantly at the back of the PV. So it can reach some resistance up to 210, which in some cases you will see a typhoon area, for example. We have bigger amount of pressure, and we have then a specific solution to be addressed. It can cope with PV modules, as mentioned, from M10 to M12, with PV up to 700 watt peak. That will, for sure, gain in efficiency and go and reach 800 watt peak. It can as well easily be configurable in several in a row, which is a concept that has been brought back from 2015 when Equator arrived on the market. So basically, we place one maintenance column every 1, 2, or 4 row of PV. So that's what we call several in a row configuration. It can adapt to specific temperature range as well as snow load, especially in some region. And it can cope with corrosive and UV in some specific challenging environment. One last part is about the material, which is something really important at Ciel Terre, as we are ensuring that the product can be reliable and can be installed for more than 30 years. So basically, we have a close look at what we select as a raw material. Talking about evolution, Optim features new floats overlapping design to make maintenance column better for the safety, basically. So it brings Hydrelio float-to-float technology closer to hybrid and rigid working stability, while keeping a high degree of flexibility to cope with the waves. It allows a better weight repartition on the maintenance column, as well as ease of maintenance and operation. Columns can be easily added to the power plant without compromising the overall array density, and while adapting to heavier string inverters, which are placed directly onto the floating array, or DC box that can be placed as the same on this specific maintenance alley. This Optim paved the way to an upgraded float-to-float structure, basically, with the latest PV compatibility from M10 to M12, with the latest PV weight compatibility up to 38 kg, with improved thickness repartition during the blow molding process, with a better safety, as mentioned before, with the maintenance floats concept, and with adaptive floats to cope with PV tilt and PV dimensions. Now that we talk about the solution for actually the market, so the CT adapts its product to market trends, improving the system, of course, but CD adapts also to site constraints. And I want to hear about you, about what you have faced during FPV project execution. So here is a quick poll to understand where you find the different limitation. Thanks for voting. So I see that site constraints came first here in the poll, followed by anchoring issues and environmental issues. It's true that those specific problematics needs to be handled with care, and Ciel Terre is making everything impossible to reach those points. We'll see specific cases now with the presentation. So as mentioned, we need to overcome some site challenges, and this is the last part with the first coming to the anchoring. So site characteristics are essential to lead some unique design and at some point to innovate and think out of the box that you will see during the presentations with anchoring, because at some point we can provide a unique anchoring design to the customer depending on the site requirements. So let's have a look at Maiwelt Project in Germany. It was installed in 2019 on the Quarry Lake. The capacity reached 750 kilowatts. And on this specific project, Ciel Terre scope has handled project engineering, supply and procurement of the floats and anchoring, as well as the construction. Challenges on this specific pond were that Maiwelt was Quarry Lake still in operation, so the location of the power plant matters a lot because we didn't want to interrupt the actual activities on the lake. Second, that was about the depth of the reservoir. It was 40 meters at the location of the FPV, and at that time, for a small capacity as this project is, it was quite expensive to go and install some anchors at the bottom of the reservoir. And last part is about the impossibility to install some bank anchoring on the west side, as the quarry activity was still running specifically on the pond. So we came with a new type of system called Parabolic line. The concept is that we have a main line that is set between two anchor points, and we have bridle lines that connect the main line to the anchoring floating array, basically. This brings several advantages. So we can name first the actual solution that we avoid to disrupt the activities. So it means that we didn't do any bank anchoring or bottom anchoring, specifically on the west part. It was required less anchoring points, as you can see specifically on the screen. It was quite quick, so there was no impact on the actual installation duration. And depending on the soil condition, it could be as well less expensive than traditional mooring. But it's not to mention that a design like this must be adapted to site constraints and construction feasibility. It's simple. It looks simple on the screen right now, but it's a bit more sophisticated with specific simulation and calculations. Now let's move to the second anchoring challenge on a specific project. Here is Tamsui Project on a fish pond reservoir that has been installed in 2022 in Taiwan. The capacity reached more than 1 mega, and the actual scope of work for Ciel Terre here was the project engineering, supply and procurement of the floating and anchoring, as well as the construction. On this specific project, the challenge were that it was still in use for the actual fishermen that were catching and harvesting the fish. So part of the pond couldn't be used for the actual installation of the floating power plant. Second is that the pond can be entirely dried for several reasons, such as maintenance and operation or dredging. Sorry. And last one is that the bank were made of concrete and couldn't be used for the actual anchoring design of the power plant. So what we brought on the table here called pillar anchoring, which is a concrete pile that is set vertically into the ground, on which we have a buoy that adjusts to the water level and that connects directly to the anchoring equipment on the floating solar array. The buoy slides along the piles to cope with the difference of water level variation. And it can even go to no water level, as mentioned here, as it follows strictly the water elevation. It brings several advantages. First is that the mooring line is always tense, horizontal, and shorter at some point compared to traditional mooring if we would have done it at the bottom of the reservoir. It's increased the overall space for the installation on the floating, so the capacity was increased with such specific anchoring scheme, and it avoids asymmetry impact on the anchor elevation. Next topic, so we've seen two different anchor challenges so far, and now we are moving on to a second challenge, which is the nearshore application, and we'll have a look with the specific project of Chongbing 1 in Taiwan. So this project has been installed in 2020 in a nearshore application with industrial conditions. The project reached 88 megawatts so far, and the actual scope of work specifically on this project was project engineering, supply and procurement of the floating structure only. Specifically on this project, challenges were quite important. First, we can mention the corrosivity of the environment, as well as the salty water coming onto the plant, corrosivity from the industrial area, basically. We can name as well that the tide is coming twice a day to the pond, to the area. So it means that we have sometimes the plant laying directly onto the ground. We have the fact that it is a typhoon area, so it has to cope with high wind and severe environment for this specific challenge. And last challenge that we name here is the soil condition that were not so easy to handle with. So how did Ciel Terre tackle it? We've done a lot of different press study, also some quality study about the water, about the soil in itself. We've run as well a pilot directly on site to cope to understand in which environment the pilot will evolve. And basically, we went through a third-party technical due diligence, so replying to specific questions to make sure that the project can stay for the overall lifetime of the project. We've developed a specific fixation system for the project itself, and we adapt the construction to the tides, to the waves and wind that were coming to the unit that we can see here on the screen. So we adapt the shifts of the construction based on the specific site constraints. And last but not least is that Hydrelio is a float-to-float technology. So very flexible technology that can cope with the actual fact that it could be completely dry. So the technology can lay directly onto the ground. Just to mention here that the project is actually under extension. So nearly 200 megawatts will be connected by end of this year, which will bring the overall capacity for floating on this specific area to 450 megawatts, reaching and will be the world's biggest FPV system in the world. Now it's the third part of the field application and case study with an example from Kayamkulam in India, where we had some sites challenges and requirements from the project timings. This project has been installed in 2022 on an open sea waterway with some brackish water coming to the actual floating array. The capacity was exceeding 33 megawatt peak, and the scope of work here for Ciel Terre was project engineering, supply and procurement of the floating and anchoring, and installation construction. First challenge here to mention was that the large quantity of floats to be produced and delivered in a short timing while keeping high quality standards. And the strategy here from Ciel Terre is that we keep the floats by ourselves. So we make the floats directly ourselves. We invest into a specific manufacturing line to produce the floats close to the site and to deliver in time the quantity that was needed for the project. About the quality control, we have a strict quality control in Ciel Terre that we apply to our manufacturers and that were actually applied to our own manufacturing line with real-time tests and with specific inspection during the production and also at the end once the products are delivered on site. Second challenge here is the construction timings that were as well quite challenging. So we cope with this specific challenge by adding new platform onto the pond, basically to accelerate the construction of the overall floating array. And the assembly, so at the end, the assembly of the overall structure was made possible in 70 days. The unit towing was increased to 0.5, as you can see on the right bottom picture. So it's as well keep going for the construction. It was something essential to tow a bigger unit. And here specifically on this project, we had restricted areas. So we were constrained as well with the sites. But as Hydrelio is a float-to-float connections that is very modular, we were able to install it on a small space. So taking part of the road for the storage and extending platform area over the water body to assemble a structure. Last one is about the harsh weather condition that we've seen on site with monsoon and heat waves. And basically, we could adapt directly some equipments for the local construction team, and eventually as well providing some temporary marine anchors for the towing unit, because those units were directly drifted to the final location, which was 3 kilometers away from the actual assembly lines. This ended up the presentation for today. As a summary, innovation and floating solar aspects intervene at different stage. First is anchoring. We can name anchoring, product, construction, as well as project. But what is essential for Ciel Terre is that the anchorings comes always along the floating PV structure. This is something essential for getting bankability and reliable project, basically. Because at Ciel Terre, we ensure that there is a specific study and specific anchoring team that have 13 years of expertise and experience over 290 projects overall. They face multiple types of computational fluid dynamics to better understand the behavior of the plant, correlated with wind tunnel, same as lots of different anchoring tests that have been performed in real scale condition with more than 100 floats, and as well as some monitoring of some installation to keep an eye about the behavior of the plant throughout the years. So all those is fundamental for us to keep the floating project bankable and reliable. Thanks for listening. Hope you enjoyed the presentation. Now you can go to the Q&A sessions.
Thank you, Thomas, very much for a really great and hands-on presentation with really good examples. So we do have had quite a few questions coming in from our audience, and we have some more minutes to attend to them. So the first question from our audience is by Andres Franco. Can your system support PV panels with more than 2,300 millimeter length?
Exactly, as mentioned, Optima System is a float-to-float technology with specific floats that can be adapted to this kind of PV technology, so G12 or M12 technology, as we call. So it can go up to 4075 millimeter long. So it can, of course, cope with this kind of PV.
Mm-hmm. Thank you. The next question is, why place projects in high-risk places like Taiwan, where there are typhoons, for example, and what are the benefits to that?
Basically, it's similar to Japan. Taiwan is similar to Japan, so there is a higher necessity to have some power plants based on the land, but there is a constraint because of this land. So they use water surface, and as the potential exists in Asia, it exists on this specific pond, so water ponds, as well as some specific protected base. And basically, there is high risk because of typhoons, but Ciel Terre actually have some expertise about designing some FPV plants on these specific strong environment loads, and we can adapt and have a strong knowledge for floating at some point on this specific segment and this specific challenge.
Mm-hmm. Thank you, Thomas. Another question we have is, have Ciel Terre installed any bifacial panels on any projects?
Yes, we have. Basically, our clients used in the past bifacial modules. Basically, there is no specific studies on whether about it increased the performance, but for sure between bifacial and monofacial. But for sure above water, it is commonly said that bifacial performs better because of the backsheet. That there is no backsheet at the back of the PV because of the humidity. It can as well have some degradation. So we would recommend to use bifacial on our FPV, but it all depends on the end client at some point.
Mm-hmm. Thank you. Next question is, could you please address the cooling effect behind the panels and the reduction of evaporation from the water body?
Basically, from the water body, so it's very specific to the location of the project. There is numerous number of scientific research on the topic about the cooling, about how to handle this kind of specific question, because it is commonly said that FPV increase the overall efficiency of the PV because we are based on water. If we can take Ceres, actually Solar Energy Research Institute of Singapore, that made some studies on the topic, we observed that the yield could increase by 5 to 10%. It as well depends on the actual structure that you are considering. If there is a canopy system without any access to the wind at the backside of the PV, it can as well impact. So depends on the location and depends, and if you have some pilot project that could have some specific device to calculate this water treatment beforehand the overall project, it would be very interesting for you in order to understand what would be the acceptable increase of yield.
And what is the maximum tilt that could be achieved?
Depends on the actual PV that you can use, but the system can adapt to 5 degrees and 12 degrees. So we have 2 tilts that are available in different type of configuration. We can even imagine a canopy system with our specific floating structure, but 5 to 12 degrees.
The next question is, can you give more details about the options that are available for when there is snow on site, and can someone use Ciel Terre technology for that?
Of course, we can use Ciel Terre technology for snow environment until a certain extent. Float-to-float technology like Hydrelio Optim floats can withstand some snow loads, as it can withstand some workers or even some string inverters. But a more in-depth study would be required to assess especially the site conditions and to better understand what is the actual behavior of the system on the specific site. So a pilot would be required. And basically, as it is a modular float-to-float connection, it's flexible. So once there is weight on the specific float, it will be a bit spread on the other floats, but not so much. So at some point, we've done several projects in which we experience very cold regions, very cold environments, such as Korea, South Korea, or even North America, with our float-to-float technology. And if you want to go and have a specific study on the topic on snow related load, don't hesitate to contact our team and to assess the environment from our point of view.
Moving on to the next question, which is, I understood that the Hydrelio system could land on the ground, but isn't there any damage if the ground is flat? Won't the system get stuck if it stays on the ground too long?
It could happen at some point if the land is really, really soft, really, really thin with a specific soil condition. And what we've seen so far is that it's never happened. It happened that the float can still have at the back of the float we have some shapes that avoid this kind of issue to keep the float and get the system directly stuck into the mud, I would say. So it never happened on the pilot that we've seen, and it never happened on the actual site that we propose and on the actual extension that we propose on the project in Taiwan.
And if the depth is more than 40 meters, which type of mooring system will be recommended by you?
If the actual case happens, so more than 40 meters, we need to have a look at the overall type and condition of the soil itself, because one anchor could fit, but other could be as well used. It really depends on the geotechnical feasibility. So it could be dead weight, it could be screw anchors, it could be different type of anchoring. Depends on the actual soil condition and the actual capacity that you want to withstand with the anchors.
And it is a common and commonly known problem that there's an issue with bird excrements in lakes, for example. How would you address those issues?
Basically, what we propose in several regions is that we propose our maintenance services because we know floating solar. We've been in floating solar for 13 years now. So we propose maintenance services on specific region with our specific and strategic clients. So we know better our solution, and we know how to handle the maintenance and the actual good production of the PV. So basically, we could handle directly this bird's excrement. It can be done with a specific robot going onto above the PV, but it would be done as well handling some specific specific cleaning devices onto the floating power plant.
Okay, great. I think that this was all the time we had. And I want to thank you, Thomas, for answering all of the questions. I think I bombarded you a little bit, but we had so many questions coming in from the audience. We still have some that haven't been answered yet, but I will make sure to pass them on to you, and we will find another way to get all the answers answered and out there for the audience to hear about from you. And thank you for a very insightful and great presentation. Really enjoyed having you here. And a big thank you to our audience as well for attending. I hope you enjoyed what you heard. If you want to hear more from Ciel Terre, please join our summit on the 5th of October, along with some other key leaders in the floating industry. As I mentioned in the beginning, in case you have missed my introduction, if you are attending the webinar right now, you will be eligible for a 15% discount on your event ticket. And this discount will be valid for the next 32 hours. And if you have any questions, don't hesitate to contact me. And thank you for joining. I wish you a great rest of the day.